All right, hello, ladies and gentlemen. Today we're looking at the Skills N1 and N2, which have to do with sine curves, sinusoidal functions, specifically sine for these two. The nice thing is that the next skills N6 and N7 are basically the same thing. It's just talking about cosine. So if you get the sine skills down really good, then the cosine is pretty much the same thing. All of these are good little formulas that you need to know, and all things that the IXL program is going to ask you for. So amplitude, we know that if I have a sine curve, and if you remember, sine was middle, high, middle, low, middle, and that's our sine curve. Then the amplitude is half the distance between the max and the min. The amplitude is the distance from what we might know as the midline to the maximum value. And so this distance represents the amplitude. And you can see that they have it as a positive value. Because of the absolute value bars, we always say amplitude is a positive value. And it's pretty easy to get. We've done it before where we would just say halfway between the high and the low. So that's what we did when we were writing equations. So this little distance between the midline and the maximum is the amplitude. The period is the distance between two consecutive maxima. That's how IXL defines it. But really, it's the distance between the whatever values start to repeat the pattern. So from here where we might start and here where it ends for a sine curve is on the midline. Yes, it should be the same between two consecutive maximas, but usually that we can see more easily on a cosine curve. And you might be able to do that for most of these problems in IXL too. So you can either go from maximum to maximum if this were to continue on. So you could say, here's another maximum, the first max and the consecutive next max. And then all you have to do is subtract to get the period. And then the same thing here, we could do the ending minus the starting. So that is the period. We can also use the formula 2 pi over b if they give us a model. So if they give us this model for an equation of a sine curve, then you can figure out the period just by doing 2 pi over the absolute value of b. So 2 pi over b also gives you the period. Frequency we haven't talked about, but it is just the reciprocal of period. So that's not something I would have talked about, but IXL might ask you for it. So it's just the reciprocal of period. So if you know the period is, let's say, 3 over 4 is the period, I don't know, then frequency would be 4 over 3. So it is just the reciprocal, so flipping the fraction. The midline is an equation. It is y equals some number. In this case, it would be y equals 0. And the vertical shift, if they give you an equation, the vertical shift is just this movement d, whether it's a positive 4 or negative 4, or whatever that d value happens to be. They might also ask you for the phase shift. And at the phase shift, if they give you an equation, then all we're doing is taking all this stuff with x and setting it equal to 0 and solving for x. That's also known as the horizontal shift. And if you remember when we were talking about translating functions, all these things, these values inside with x are shifting the function left and right in the x direction. And so they say phase shift. It's another way for just how much is this curve shifted over to the right a couple spaces or maybe negative a couple spaces. So all of these are good things to know and have written down. Remember, feel free to pause the video as you go. It might be a good idea to look at the question and then try to answer it and then let me explain it. So take a good look at our first curve here. We have a graph of a sinusoidal function. I say sinusoidal. Sinusoidal just means any sine or cosine curve. A sinusoidal movement is just a movement that oscillates between a maximum and a minimum. So that's a sinusoidal movement, sinusoidal curve. So go ahead and take a minute and just really pause the video and just try and figure out these, the answer to these A, B, C, and D using the graph here. And you might need to zoom in if you can't quite see it. And I do think this question is maybe a little bit harder than what you'll see on the IXL today. All right, so the first thing we want to figure out is the midline. And according to what I just told you, the midline is an equation, y equals some value d. And we can calculate that a couple of different ways. So if I want to find the midline, now we've done this before, the midline is the middle, really, of the highest and the lowest value. So here our maximum is occurring at 5. And here we have a minimum, which is occurring at -1. So the midline is halfway between the highest and lowest value. So I want to calculate it halfway between the lowest and the highest. And so that's going to be halfway between -1 and 5. So that's going to be half of 4. Half of 4 is 2. So this is the vertical shift. It's a vertical shift of 2. But if they actually want the equation of the midline, then we would write y equals 2. If they are just asking for vertical shift, then the vertical shift is 2. The amplitude, so I'm going to go ahead and draw in that midline of 2, and most of the time I think you'll probably be able to just see the midline. So here's our midline, y equals 2. The amplitude is the distance between the midline and the maximum. So this distance represents the amplitude. And I mean, I can see that that distance is 3. Pretty easy to see, but we could do the maximum minus the midline. So 5 minus 2 gives you an amplitude of 3. And remember, an amplitude is always a positive value. It's different than A. All right. A is any number, but amplitude means a positive value. The period is how long it takes something to repeat. So the definition that IXL gives is to go from maximum to the next consecutive maximum. So the second maximum would be here. The problem is I don't know exactly where that is. It doesn't fall very nicely. So I'm going to look for where my curve starts to repeat itself. And I have lots of choices, but I'm going to go with this one right here where it's crossing the midline. It happens really nicely. And then we go middle, low, middle, high, and back to middle. And that's when the curve starts to repeat itself. So these are 2 consecutive repeating values where our curve is going to start going in the same direction. We repeat here, but our curves go in different directions. So to the right, it goes down, but to the right of this point, our curve is going up. So that's not technically repeating. So we want where our curves are going in the same direction. So here we have the start of one period and the end of one period. And if I want to find the distance between them, all I need to do is subtract the ending minus the starting. And in this case, we're ending at 7 pi over 4 minus the starting value of pi over 4. Of course, common denominators would be great. 7 pi's minus 1 pi is 6 pi's over 4. And absolutely reduce. I can divide by 2. So 3 pi over 2 is the period. Make sure you reduce. IXL is notorious for making sure you know how to reduce. Frequency is just the reciprocal of period. So all we have to do is flip this period. So that's going to be 2 over 3 pi. And that should be a fine answer. All right, so that's good to go for that one. So that was given a graph. Our second example is given the function. So again, it might be a good idea to pause the video and try and answer these things yourself, just using the information from the first slide. Okay, so here we have our equation. And of course, when in doubt, graph it out. You could type this into your calculator and look at the graph, but just having the equation is good too. Remember, we're working with the form A sine bx plus c plus d. That's the form IXL is basing their information on. Back at that first slide, bx plus c plus d, and that's important to know. We used I think we used bx minus c when we were doing this by hand, but it doesn't really matter. So the vertical shift is the d value. This is the vertical shift. And so in this case, the d value is -6. If they asked what's the midline L-I-N-E, would be the equation y equals -6. So be very careful. They're pretty particular. But the vertical shift is just -6, down 6. The amplitude is the absolute value of whatever the A value is. And so in this case, it's the absolute value of -4, which is just 4. So our amplitude is 4. Period, when you're given an equation, is 2 pi over the absolute value of B. Here, our B value is 4/3. So we would have 2 pi over the absolute value of 4/3, which is just 4/3. And I don't like dividing by a fraction, so I'm going to multiply by the reciprocal. So that's going to be 2 pi times 3/4. Which is 6 pi over 4, which reduces to 3 pi over 2, which you'll notice is the same as the other page. The frequency would just be the reciprocal of the period. So I could work it out. Let's see what happens. So frequency is the absolute value of B over 2 pi. So again, absolute value of B is 4/3. Whoops. And again, the absolute value is 4/3 over 2 pi. Well, I don't like when I have a fraction and I'm dividing. So I'm going to, again, multiply by the reciprocal. That's going to be 4/3 times, this is 2 pi over 1. So the reciprocal would be 1 over 2 pi. And you can see we would get 4 over 6 pi, which again reduces to 2 over 3 pi. So if you have the period, it's easy to go ahead and flip it to find the frequency, but maybe they didn't, they just asked for frequency. You could still work it out and get the same thing. Phase shift is also known as the horizontal shift. And horizontal shifts always come from what's affecting the x values, the horizontal axis. So to find that, I'm going to take all of this stuff that's inside with x. 4/3 x plus 5 pi over 3. And I'm going to set it equal to 0 and solve for x. That's going to give me my horizontal shift. So isolating x, I'm going to move over the 5 pi over 3. So we have 4/3 x equals -5 pi over 3. And then again, to get x by itself, I'm going to multiply by the reciprocal. Those cancel out, leaving x by itself. I'm going to multiply straight across. Oh, heck no, I'm going to reduce. 3 goes into 3 once. So those reduce, which is nice. We're left with -5 pi over 4. And that is the phase shift. So the phase shift is -5 pi over 4. And that's what you can type in to your IXL field. All right. Hopefully that's pretty good. And now we get to figure out the equation of the sine function. So we are actually going to calculate the A, B, C, and D values, where A, B, C, and D are real numbers. What are real numbers, ladies and gentlemen? All the numbers you can think of, positive or negative, whole numbers. They are fractions. They are irrational numbers like the square root of 2 and the square root of 3 and 2 radical 2. They are irrational numbers like pi and e. What is e? Not quite 3. All right. So these values, a, b, c, and d, can be any number you can think of. What they can't be are imaginary numbers. All right. These are the real numbers, not the imaginary numbers. Okay. So let's see what we can do. I think when we would do this, the first thing we always found was find D, the midline. So I can see really easily that the midline here is at y equals 4. And that was really easy to just see visually. If you wanted to calculate it, D is halfway between the low and the high value. Our lowest value minimum is at 2, and our maximum is at 6. So we can see that halfway between our low value and our high value, 2 plus 6 is 8. Half of that would be 4. So D equals 4. So whether or not you can see it really quickly, or if you want to calculate it, you have that option. From there, the second step we would do is actually figure out the A. So the first thing is the D, and the second thing is the A value. The A value, again, maybe you can just see it. A is like amplitude, but we do want to figure it out fairly easily. So let's see. On here, it looks like the distance between the midline and the maximum is 2. So the amplitude is equal to 2. Now, that's not the value of A. That's amplitude. I haven't decided if this curve is a positive sine curve or a negative sine curve. So we can decide that a little bit later. But if you want to calculate the amplitude, then it is the maximum minus the midline. So our max was 6, our midline was 4, and the difference for those is 2. So again, that's amplitude, not the same thing as our A value. So we do have to come back to that. Now, we have to figure out our value for C. Well, B x plus C. We have to choose that first. So before I do that, I actually want to go ahead and just figure out a sine curve that I like. So I think, for myself, I see my sine curve. Remember, sine starts in the middle from the midline. So I see middle, low, middle, high, middle. So there is one sine curve, and this sine curve happens to be a negative sine curve. So I think I'm going to use this one. And the reason I'm going to use this one is because it starts at 0, which is really, really nice. If I can start my curve on the midline at 0, then that's a great place to start, because that tells me my C value is 0. Hey, yay. Okay, so now what I need to do is figure out B. So the third step is to find B, but the only equation we have for B is actually involving period. So the first thing we need to do is find the period. Oh, that's not how you spell period. P-E-R-I-O-D. All right. And so the period is the time or length it takes to complete one cycle of our curve where it starts to repeat itself. So you can see that we started at 0 and we ended at 3 pi over 2 for one complete cycle of our curve. And the period is just the distance between them. So all we have to do is subtract the ending point minus the starting point. And so in this case, we ended at 3 pi over 2. And we're starting at 0. Now, I could choose a whole nother period of this function if I wanted to, and you'll see that if we started here and ended here at 3 pi, if I did 3 pi minus 3 pi over 2, I'll still get 3 pi over 2. It happens every single time. So it should always be the same period. So here we have our period is 3 pi over 2. Now, we know the period is 3 pi over 2. We also have a formula that involves B. we know that period equals 2 pi over b, or the absolute value of b. Our period is positive anyway. So we can actually rearrange this formula if we want to. I'm going to go ahead and multiply by b. So, and then divide by the period. So it turns out b is 2 pi over the period. So I know the period, and that's going to help me figure out b. 2 pi divided by 3 pi over 2. Again, I don't like dividing by a fraction, so this is going to be 2 pi times the reciprocal, 2 over 3 pi. My pi's are going to cross out. Pi on top, pi on bottom are going to reduce, and we're going to get 4 over 3. So our b value happens to be 4 over 3, and so we can plug that in. And in this case, my c value happens to be 0. And I think most of your equations should be pretty easy. My amplitude, because this is a negative sine curve, because my curve has, because my curve is going, is a negative curve, it's the reflected curve, my a value, we said, is going to be a -2. So be very, very careful since we're just modeling this little section. Let's see. So my a value is -2 times the sine of bx. So b is 3 pi over 2 times x. In this case, our c value is 0, which is really, really handy. And then, so you don't actually, I'm not even going to bother writing that. You don't have to include it, I don't think, on IXL. And then our d value is 4. And of course, you can use your calculators. I'm going to use the Casio. So I'm going to go to setup and make sure that I'm in radian mode. There we go. Angle, degrees. Don't want that. Radians. Okay. All right. So I'm in my graphing mode here. All right. We have -2 times the sine of. Now I'm going to make sure that I have all of this stuff in the numerator. So I'm going to do 3 pi x in parentheses. 3, and then pi is at the bottom. Pi x divided by 2. And then my plus 4. And I'm not exactly sure if that's going to be a very good window, so let's just draw and see what it looks like. Well, it looks kind of close. What I'm going to do is I'm going to make my window look just like this one period here. So I want my x-axis to start at 0 and end at 3 pi over 2. So I'm going to change my viewing window. On the TI, you would change the window. I'm going to go make me start at 0 in the x max, 3 pi divided by 2. The scale is the tick mark. That's pi over 2 in this case. You don't really have to change that. I don't know what dot is. The y minimum in this case is 0, and the y maximum is 6. And the scale is 1. So, all right, and then we're going to go ahead and draw that. Uh-oh. Whoops. Did I do that right? 3 pi over 2. I did something wrong, ladies and gentlemen. It's a good thing we checked. All right. Something is wrong with the period. There were way too many functions here. 3 pi over 2 minus 0. Oh, did I? Oh, I didn't type it in right. Oops. So I'm not very good with this thing. It should be. No, I did. Oh, okay. 3 pi x divided by 2. Oh. Silly. It's b. I put the period in place of b. That's not right. B is 4/3. Oh, and here I am reversing it again. Look at me. 4/3 x. Oh my goodness. See how it's important to check your work, ladies and gentlemen? All right, so we're going to do delete. 4x divided by 3. How about that? There we go. Okay. And draw that. There we go. Okay, so there's our down curve there. And if you want to, again, change the window for our, so you see as many here. Let's go to 4 pi. And so you can see how it looks now very similar to, I'll leave a graph there. Sorry about that mistake. It's a good thing I checked. Yes, we went B. We use B in our equation, not the period. So be careful. Oops, there was my mistake. We're using B. B is 4/3 in our equation. All right. Always check your work, ladies and gentlemen. Oh, I have one more. All right, so this one, again, same thing. We want to calculate these values once more. I'm going to go a little faster because my time is almost up here. So the first thing I'm going to do is figure out D, and it is halfway between the lowest value and the highest value. The lowest is -5 and the highest is 1. So halfway between -5 plus 1 is 4. -4. Half of -4 is -2. So our D value is -2. I'm going to go ahead and draw that in because I think on a sine curve it really helps to have that midline in there. From there I can see pretty easily that my amplitude is 1, 2, 3 spaces. So my amplitude, the second thing, my amplitude is 3. And again, that's amplitude, not necessarily my A value. All right, now I want to go ahead and figure out B, but in order to do that, I have to figure out the period. So what I don't see is a complete sine curve. So I see middle, low, middle, high, but I don't actually have the middle here. So since we don't have a complete normal looking sine curve, the other method we can do is to figure out the period to go from maximum to the next consecutive maximum. So in this case, the period would be the ending, 5 pi over 8, minus our start here, which is at -3 pi over 8. And this isn't the start of the function. It's just going from one repeated value to the next consecutive repeated value. So that's going to be 8 pi's over 8, which is just pi. So that's the period. If we want B, it's 2 pi over the period. So this would be 2 pi over pi, which reduces to 2. So there's our B value. Now, I need to look at a sine curve. And really the only one I sort of see starting on the midline starts here. Middle, low, middle, high, and then it would come back down to middle somewhere over here. So there's one period. This is a negative sine curve. So my A value is going to be -3, since it's going middle, low, middle, high, middle, instead of the other way, which is the positive sine curve. Now, this curve is starting x value is -pi over 8. And that's what we need to use to help us figure out C. So we can solve, the very last step is to take bx plus c and set it equal to 0, which would be our starting point, and plug in what we know. B is 2. Our starting x value is -pi over 8. Plus c is equal to 0. And I'm just going to go ahead and here, this is -2 pi over 8, -pi over 4, plus c equals 0. And I can just move the pi over 4 over. So that's the value of c. So we can solve for c, and I can plug in my values, and then we'll be done.